Hi, I'm Major Madrigal and I'm doing Lab 5, Practical number 1. This is my circuit right here. And this is my motor. Right now I have a sine wave going into it and it's just oscillating back and forth. In my circuit here, I have the resistor being in parallel with the capacitor, and from the pot, the result is coming in right here from this red wire.
Then I'm using a sine wave, and here's how it is following. The yellow one is the input, and the blue one is the one coming from the pot. As you can see, it closely follows, but there is some difference, and that is due to some noise. And if I switch it to a triangle wave, I still get the same thing, and it still follows it very closely. And now if I switch it to a square wave, as you can see, it first oscillates a lot when it first tries to get to the initial, and that is because there is some noise, and it takes it a little while to get to its initial because there is some underdamping. To get it to better reach the value I desire, I need to increase the capacitance.
If I want to increase the capacitance to 2, I have to put it in parallel with my circuit.
Now if you look at it, it is oscillating by much less. It only has like 2 waves now. And if I want to decrease it even less, I can increase my capacitance to 3. Now if you look at it, it only oscillates like 1.5 times to reach my initial value, which means I am increasing the dampening in my system, but it's still a little bit under damped. And that's why it doesn't go to it initially.
Now if I want to increase it to 4, I again put it in parallel to my circuit, and these 2 are connected over here to where I had the other ones, but since they all didn't fit, I put the circuit over here so I could put them in parallel.
Now when you look at the wave, it only oscillates 1 time, which means that I'm getting closer to the desired, and by increasing the capacitance in my circuit, I get it much closer to the desired input wave much sooner instead of oscillating way more. So my final conclusion is, as you can see, my input sine wave, my input square wave closely follows, well, my output sine wave my output square wave closely follows my input square wave, except for the little oscillation at the beginning, which is the resonance.